Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is Lesson 6-1 on inverse functions. Let's get right to it. Today we're going to understand how a function is one-to-one. We're going to find the inverse of a linear function, and we're going to find the inverse of a nonlinear function by limiting its domain if necessary. So let's talk about the definition here. A function f has an inverse function denoted f with what looks like -1 power, but when it's on the function notation, it's going to imply inverse. If and only if for any input value x, excuse me, in the domain of f and the functions resulting y in the range of f, there exists a new function where the y produces the original f from the original function. In simple terms, it means this. If I take x and I plug it in to the function f of x, I will get a y out. If I take that y and plug it into the inverse function, I should get this original function back out. So basically, the inverse function undoes the process that was done to the original x in the first place. So we must note, for a function to have an inverse, both of the function and its inverse must be one-to-one. Now, what does that mean? Okay, so here are two functions. I'm just going to draw them to be, in general. So let's talk about a linear function, and let's talk about a parabola quadratic function. All right, for a function to be one-to-one, a function is one-to-one if and only if for every element in the domain, there's exactly one element in the range, and for every element in the range, there's exactly one element in the domain. Now, we can understand what that means graphically if we talk about a vertical and a horizontal line test. For a relationship to be a function, it must pass a vertical line test, meaning anywhere that you pass a vertical line along the x-axis, that vertical line should only cross the relation one time. That makes it a function. Same thing over here. Any place that I pass this vertical line, that vertical line crosses the relation at only one place. So in both instances, this linear relation and this quadratic relation are functions. But it must also pass a horizontal line test. So when we talk about this horizontal line test, we see that this relation passes through the horizontal line at two places, whereas this relation, this linear relation over on the left-hand side, only passes the horizontal line through one place. So what we can say here is that this one, this linear function, this is a 1-to-1 function because it passes both the horizontal and the vertical line test. This is not a 1-to-1 function. All right. Excuse me. All linear equations are one-to-one and have an inverse. So the process for finding inverse is going to check to see if the function is one-to-one. If not, limit the domain. We're going to switch our x and y values in the function, and then we're going to solve for y. Graphically, the inverse of a function is a reflection about the line y equals x. So first, let's talk about limiting the domain. So in this one back here that we had, what we could do if we wanted to have it be one-to-one, we could limit the domain and get rid of this portion of the graph. Now, if we only talk about the values of x that are greater than or equal to 0, then we can talk about that being a one-to-one function, even if we can't do it. So we'll have an example where we will have to limit the domain at some point. All right. And then let's talk about I'll show the graphical interpretation here in a little bit. So function notation for inverse, if we talk about a function f of x, then the inverse is f inverse, and that's how we read it. And we'll use that little notation with a superscript -1 as the inverse. And the question will be posed to you as find f inverse of x given some function. All right, to show the two functions, f and g are inverses of each other, you must compose f with g and g with f, and they must both reduce down to x. And that makes sense because when we compose functions, we're basically plugging a function into a function. And so if we want to see that two functions are inverses, when we plug the one function into the other, we get the original thing back out. And that's what we're looking for there. All right, let's talk about an example of that to show that the functions f and g are inverses of each other. So what we're going to do is we are going to find f composed with g of x, and we're going to find g composed with f of x. All right, and so this is f of g of x, and g of x is this 4x plus 9, and then f is x minus 9 all over 4. So it's something minus 9 all over 4, and that something minus 9 all over 4 is 4x plus 9. And so 4x plus 9 minus 9 is 4x over 4, and the 4's cancel, so I just get x, which is what we're looking for. The composition of f composed with g reduces to x. We also must do g composed with f of x, which is g with f of x plugged in to that function. Excuse me. Now, g has this expression here, and we're going to plug x minus 9 over 4 into g. Now, g is defined as 4 times something plus 9, and that something is this expression. So x minus 9 all over 4. And because we have that 4 on the top and the 4 on the bottom, they're going to cancel. And that's going to leave me x minus 9 plus 9. Negative 9 plus 9 is 0. I get x again. And so when I've composed f with g and g with f, both of those two compositions have reduced down to x, and thus f and g are inverses. All right. Use a graphing utility to graph a function. Use the horizontal line test to determine if the function is one-to-one. So I'm going to grab my graphing calculator. I'm going to hit y equals, come on now. I'm going to go up here and turn that stat plot off from the last one. I'm going to hit delete here to clear that out. Now I'm going to check my equation again. So I need negative x square root x minus 10. So negative x second square root x minus 10. And just to be safe, let's go zoom 6, go to our standard window. And what do we get here? Oh, I'm not getting nothing. Why am I not getting nothing? Oh, maybe I can't see because let's see here. Maybe it doesn't show in the window. Let's see here. Hit graph. I got error. There we get some numbers. So I changed my window to make this work here. So let's change this x minimum to -5. And let's make this x maximum to 20. And let's go by 2's and see what we got now. Oh, getting closer. All right, so I need a little bit more. Let's change the window again. Let's go to 50, and it's going down. So let's move our y's down a little bit. Let's make that negative 50. Let's change the x scale to 5. Let's change the y scale to 5. Let's hit graph here, and oh, look at what we got there. All right. So the question is this particular function going to be one-to-one? And wait a second here. I think someone might be saying, hey, wait a minute, Mr. Cully, you graphed that wrong. It should be 10 minus x, not x minus 10. So let's fix that. 10 minus x. Oops. Let's see if that changes anything. Delete. Let's hit graph. Maybe it'll graph. Maybe it'll blow up. Maybe it'll go not responding. Oh, there we go. Now we got something completely different. Let's go zoom back on our standard window and let's fix it from there. All right, so window, one last time. I apologize for this, folks. It's my bad for not getting a good graph for you there. So twos, we'll go by twos, we'll go Y minimum, we'll go 20, and then we'll go by twos there. Oops, I didn't do that. 2. It's window. What's wrong with what I got wrong here? Oh, my Y minimum can't be bigger than my Y maximum. I need negative 20 there. There we go. All right, beautiful. Okay, now we're looking at something. So spent a lot of time to decide if we're using the horizontal line test to determine if the function is one-to-one. Clearly, this thing is a function. Anywhere I draw a vertical line, I'm going to get, it's only going to cross once. But the moment I draw in a horizontal line right here, I'm going to pass it twice. So this function is not one-to-one. All right. All right, find the inverse of the functions if possible. So first thing we want to do is we want to look at this thing in 2x minus 5. So if I go to my graph and I go clear this out, that was a pain, 2x minus 5, and I go zoom 6 and graph that. That is a linear function, and we already had a rule that says all linear equations are one-to-one and have inverses, and there's an asterisk because a horizontal line and a vertical line will not have an inverse. So how we're going to do that? Well, we're going to switch x and y, and so we're going to go x equals 2y, excuse me, minus 5. Switch x and y, and then solve for y. And so here I'm going to add 5. And so I'll have x plus 5 equals 2y. And let's flip that. And I'll have 2y equals x plus 5. And then we're going to divide by 2. Give me y equals x plus 5 all over 2. And then we'll rewrite for final answer. And then it'll give me f inverse of x equals x plus 5 all over 2. All right, so same thing here. We're going to switch x and y. And that'll give me x equals the square root of y plus 4. And I suppose I should take a second. Let's graph this thing first. Let's go to our y equals. Let's clear this out. Second, square root x plus 4. Oops. Clear one more time. Second, square root x plus 4. And let's go to the standard window. And clearly, this is a one-to-one function. Vertical line test, it passes. Horizontal line test, it passes. We're good there. So I switch my x and y. I'm going to solve for y. I'm going to square both sides. And so I'll have x squared equals y plus 4. And we're going to subtract 4. And that'll give me y equals x squared minus 4. Now, notice I have this y squared. So I'm going to graph this. And let's do it in a separate window here. So I got x squared plus 4. not 54 there, Macaulay. Delete. Let's just go x squared plus 4. Now, when I graph this function, I get this one-to-one function. When I graph this function, it's no longer one-to-one. In fact, this function clearly, if I drew a horizontal line there, would not be one-to-one. So we're going to limit the domain. And the way we're going to do that is we're going to limit it so that we are only talking about these values right here. We're going to kind of scratch this part of it out. And the way that we're going to do that is we're going to enter a little bit of what's called a domain limitation. And we're going to go f inverse of x is equal to this x squared minus 4. And then we're going to say where, we're going to put a semicolon there, where x is greater than or equal to 0. This thing right here limits the domain to keep the inverse one-to-one. All right, that's all I have for today, folks. So the Marvel fun fact of the day: in Iron Man, Tony's sidekick AI Jarvis name stands for just a rather very intelligent system. Jarvis. And it's right there, Jarvis. All right, that's all I got. Have a good day. Bye.